This is section 2.6. It is dealing with special functions. We've graphed linear functions. We will graph quadratics. These are all special functions. They're not really linear, they're not really quadratic. There are several different types of special functions we're going to look at, and they have names. There's a piecewise function, which is what we're going to look at today, where you're graphing individual pieces of a function. There are step functions, where those look like stair steps, and we'll look at that next week. And then we have greatest integer function and absolute value functions. We have some different functions we're going to look like. Step function and greatest integer are pretty well the same thing, but just different names given to those types of functions. Today, again, our focus, and today and tomorrow, really, our focus is going to be just on these piecewise functions. And you'll need this graph paper, this handout that you have, to graph. Please make sure you ask questions today, take good notes, write down good examples, because these are new. It's a little bit different way of thinking, so do take good examples as we go through these problems. If you look at your first example, again, this is called a piecewise function because you're graphing individual pieces. Normally when we graph something that we don't know what it looks like, we create an XYT chart. In our case, we have 2 pieces, so we're going to need 2 XYT charts. So that's the very first thing I'm going to do, is I'm going to make 2 XYT charts. 1 T-chart per piece. There is something that you've got to pay very close attention to. In the first piece, do you see where it says x is less than or equal to 3? Put that above that first XYT chart. Our second piece says x is greater than 3. We are limited to the values we can use on our XYT charts. We are limited to the x values that satisfy this inequality. We can only pick x values that are less than or equal to 3. And the second one, we can only pick values that are greater than 3. Now, 3 is what we call an endpoint, so we will have to pick 3 in both of our tables. So in the first table, we have to pick 3. It's our endpoint. So 3 is going to be one value I put in. Give me some more values that are less than or equal to 3. 2, 1, 0. There's 4 good points that I can select. So let's put in these values to our function. Well, our function is right here. It's saying f of x is equal to x minus 1 if the x values are less than or equal to 3. So these values are less than or equal to 3, so I'm going to put them in for x minus 1. So if I put 3 in here for x minus 1, what do I get out? What is 3 minus 1? 2. Put 2 in. 2 minus 1 is 1. Put 1 in. 1 minus 1 is
0.
Put 0 in. 0 minus 1 is? Did I have to stop at 0? Was that the last point? No, I just stopped there because I had 4. So I could put negative 1 if I wanted. Put negative 1 in. Negative 1 minus 1. Negative 2. Put negative 2 in. Negative 2 minus 1. I could keep going, correct? Could keep going. I'm going to go ahead and graph this piece of your piecewise function. The first point we plot at 3, 2. I'm going to use a closed circle here because if I put 3 in, my inequality, my domain is telling me that 3 is included, correct? When it's less than or equal to, 3 is included. So I'm going to use a closed circle. Use a closed circle. The second ordered pair, 2, 1. 2, 1. 1, 0. 0, negative 1. Negative 1, negative 2. Could you continue this pattern? I mean, it looks like we're going down 1 and left 1 every time. We can continue down 1 and left 1, down 1 and left 1. Without picking values, we can continue this. Now, I want to draw in my ray. Do you know what a ray is? It's a line with an endpoint and an arrow going one direction. It's not a line, it doesn't have 2 arrows. It's an endpoint and has a line, arrow going in one direction. So where does my ray begin? Right here at that first point. So my ray is going to start here. I'm going to go down this direction. to put an arrow on the end of that ray that shows that it does keep going. It keeps going. Now, all of these x values are less than or equal to 3. Do you see that? I'm thinking domain, so we're going to have to do domain here in just a second. My x values begin at -3, and they all go to the left, correct? What about my range for this piece? What is my highest range value? 2. Everything else, all my other y values are below 2. Okay. So we'll get to domain and range here in a second. We're not ready to do that. Let's go to the second piece of our piecewise function. This one right here. This time I've picked values that are greater than 3. Now that's kind of misleading because 3 has to be the first value I put in for x because it's an end point. It's an end point. I have to put 3 in. So what are some other values I could put in for x? 4, 5, 6, 7, 8. I can put anything that's bigger than 3 in. So put 3 into our function. We're putting it in for f of x, for x. And it says if you put it in, it's going to be -1 if your values are greater than 3. So if I put 3 in, what do I get out? -1. If I put 4 in, what do I get out? -1. If I put 5 in, -1. If I put 6, 7, 8. Doesn't matter what number I put in that's greater than 3, I'm always going to get out -1. Everybody okay so far? Evaluating these functions, these different pieces. Now let's plot these points. When you plot this very first point, I want you to be careful. This is going to have an open circle. Does anybody know why I would put an open circle here? Good, it's just greater than. Think about when we do our inequalities. It's just greater than. It's not equal to, so I have to use an open circle just at that first endpoint. Just at the first endpoint. Now the rest of them are going to be closed circles, but just that first one's going to be. I've got all my points plotted. I could continue putting dots based on the pattern that's formed. And then draw that line in. I'm going to pass out some markers that we're going to use to help us with domain and range. Can we do this? Bigger marker? Don't color real hard because it may bleed through and we'll need the other side to do some more examples. So try to tread lightly when you do this with the markers. Alright, I've given you the markers to help you with domain and range. So this is what our piecewise function looks like. For domain, remember those are your x values. We're going to take each graph and we're going to squish it together on our x-axis. That's where your marker comes into play. So let's just go piece by piece. And this red piece of my piecewise function, where did my domain begin? My x values. We talked about that. Where did they begin?
3.
At 3. So put a closed circle because that's a closed circle. If I bring it down, the closed circle. So the first value, the largest value I could put in was at 3. So put a dot there at 3 on your x-axis. Now, the rest of the x values, if I take my graph and I squish it on my x-axis, isn't it going to start here at 3 and go to the left? Start here, it's going to go this direction. So take your marker and draw in that arrow going to the left, please. This is where your marker comes into play. It'll help if you've got a little bit of color. Is it bleeding through?
Yeah.
Just a little bit though? Now let's look at the second piece of our piecewise, this purple piece. If I take it and I squish it up on the x-axis, I have an open circle here, but I already had a closed circle here, so that's the closed circle is going to trump it, it's going to remain a closed circle. Where are my domain values this time going? To the right, so I'm going to draw my arrow going to the right. Notice when you did that your entire x-axis is now covered in one color, right? It's now covered in one color. So the whole thing is covered. What did we say the domain is? All real numbers. Very good. Domain is all real numbers. Take your marker and switch with somebody, please. Take your marker and switch with a different color. Do I have a different color? We're going to do range in a different color. So on your y-axis, this time we're going to take, let's start with our red graph. We're going to take it and we're going to squish it on the y-axis. Well, where do these range values begin? So let's put a closed circle because that's what we have here, closed circle. Closed circle at 2. Where do all these range values go? Yes, if we were to squish it on our y-axis, take it and move it over to our y-axis, it starts at 2. It's all going down. Take your second color and draw your graph going down, your range values. Now for this purple piece, we're going to take it and we're just going to squish it straight over on our y-axis. We don't get to turn it at all. We're just going to take it and squish it straight over on our y-axis. So when we do that, it's going to become a point right there, which is already a point in our graph, isn't it? So let's talk about range. What is our range? Well, our highest value is at 2, and everything else is less than that. So we can use an inequality to represent our range. Range is talking about y, so I'm going to say that y, all of our y values are, could they be equal to 2? Less than or equal to 2. So there's really 3 things that we're doing with these piecewise functions. Number 1, we're graphing them. Number 2, we're identifying the domain. And 3, we're identifying the range. I like using the different colors for domain and range because it helps you to visually see where it's at, and it makes it easier to come up with your domain and range inequalities. Okay. Let's go to the next example, if you would, please. This time, how many pieces of our piecewise function do we have?
3.
We have 3. So how many XYT charts are we going to need? 3. We're going to need 3. I'm going to go ahead and set up my 3 XYT charts. Above each of my XYT charts, I like to put the inequality so that when I'm picking values, I can reference that inequality, know right where I'm putting it. The first XYT chart has values that are less than -5. But remember, -5 still has to be your endpoint. It has to be the first value you put in. This second one, let's talk about it. It's telling you can pick values between what 2 numbers? -5 and +1. -5 is less than or equal to x is less than or equal to 1. We'll talk more about what values we're actually going to select. What values do you suspect we're going to pick? Well, -5, I would put it. It's an endpoint. You have to put -5 in. What else could you put in? 1. Definitely to put in 1. It's another endpoint. Anything between -5 and 1 would be fine to pick. You don't want to pick all the values, but I would pick a few. -5 and 1 are definite. You have to put those in. And the third piece is x is greater than 1. Again, 1 has to be the first value you put in. So in our first XYT chart, let's pick values that are less than -5. The first value we must put in is -5. Please write this down with me. The first value has to be -5. Even though it's not equal to, it still has to be an endpoint, or it still is your endpoint of your graph. Let's pick additional values that are less than -5. -6, -7, -8, -9. If I put -5 in for x, what am I going to get out? -5. If I put -6 in for x, what am I going to get out? -6. If I put -7 in, what am I going to get out? -8? -9? Let's go ahead and plot these points on our graph. When you do your first point at -5, -5, will we use an open or closed circle? How do we tell?
An open circle.
An open circle. Is -5 included? No. It needs to be an open circle. -5, -5, an open circle. -6, -6, a closed. Everything else is closed. It's just that endpoint that we've got to worry about. Let's talk about our domain right here. Where is our domain values beginning for this purple piece? You take it, you smash it up on your x-axis. What's the first value? -5. So everything is less than -5. See that? Isn't that what our domain is saying here? Everything is less than -5. Let's go to the middle piece of our piecewise function. The first value we have to put in is -5. Pick some other values between -5 and 1, maybe -3, -1. I'm going to put in 0. And we have to put in the other endpoint of 1. Please write this down on your paper, guys. This is a unique problem where we've got 3 pieces. Write it all down. Let's put -5 in. -3 times -5? 15 and 15 plus 8? 23. Put -3 in. -3 times -3 is 9, and 9 plus 8? Put -1 in. -3 times -1 is 3, and 3 plus 8? 11. Put 0 in. 8. Put 1 in. 5. Let's talk about how we're going to plot -5, 23. That is way off my graph, correct? Any thoughts on what we could do? Huh? We have to. That's our end point. What if I went by 2's right here? Is that okay?
Yeah.
I think so. Let's do that. I'm going to go by 2's.
Whoops.
Just my upper y-axis, I'm going to go by 2's. Now, I went by 2's, but do you notice I only labeled every other block? I'm still going by 2's. Each line's for 2, so 2, 4, 6, 8, 10, 12. But I'm only labeling every other mark. This is going to get too congested. So if we plot these points, we have -5, 23. And again, at -5, 23, -5 is included, so I do need to use a closed circle. -3, 17. Now this time, when we draw in the line that connects those points, we're going to have a segment. We're not going to have a array. We're not going to have a line. We just have two endpoints. A line drawn between. This is called a array. Excuse me, it's called a segment. Caught up here. Again, I'm just connecting those two endpoints. Remember, these are all functions, correct? They have to pass the vertical line test. If it doesn't pass the vertical line test, then you did something wrong in your graphing. So we have to make sure that these pass the vertical line test. So far, we're good. Let's go to our third piece here. The first point we have to put in is 1. Let's pick additional values that are greater than 1, like 2, 3, 4, 5, or 6. If we put 1 into our function, what do we get out? 2. If we put 2 in, we get out 2. If we put 3, 4, 5, and 6, 6. Our first endpoint at 1, 2 needs to be an open circle. Now remember, you went by 2, so keep that in mind. Wait a second, I goofed here. I apologize, I put 1. The wrong thing down there. It should all be 2s. Sorry about that. This time it'll be array, and if you have an endpoint and an arrow going to the right. Okay, so once you've got this third piece, let's take one of your markers and let's do domains and ranges. Take one marker for your domain. We're going to take each individual piece and we're going to squish them all on the x-axis. So I'm going to start with my purple piece. I'm going to take it, I'm going to slide it up to the x-axis. It looks like this endpoint begins at -5. I'm going to put an open circle at -5 because that's what I have here. And all these other values are going to the left. I'm going to go to my red piece next. I'm going to take it, I'm going to squish it down here on the x-axis. This endpoint here, if I bring it down, it's going to be right where that open circle is. What's that closed circle going to do to the open circle? It's going to close it up because that's now a value. It's part of our domain. The other endpoint is over here at +1 instead of closed circle, so I'm writing it down. And then every value in between is part of our domain. Again, please do this on your paper. Your domains. Your third piece, the green piece, I'm going to slide it down to my x-axis. Now I've got this open circle, but it's already a closed circle there, so it's going to remain a closed circle. I'll just draw in my arrow to show that those values are going to the right. What do you notice about your domain of this piece? It's all real numbers. And the entire x-axis is covered, so our domain is we can put anything into our piecewise function and get a number out. Range is not going to be all real numbers. In fact, we're going to have 3 different pieces for our range. So listen carefully. Switch colors if you haven't already done so we can talk about the range. Alright, for the range, I'm going to go piece by piece. Take this purple piece and slide it over the y-axis. We have an open circle here at -5. So an open circle, everything else is below that. Go to my green piece. I'm going to take that green piece, I'm going to slide it over to my y-axis, and it's just going to be a point. A point at what value? 2. At 2. Just a point. We can't rotate that piece at all. We're just going to squish it straight across. For our third piece, I'm going to take, let's start with our endpoint. This lowest point here would be at, if I slide over my y-axis, it's going to be there at 5. And I'm going to take this piece, I'm sliding it over to the y-axis, I'm just tilting it over. So they go all the way up until what value? 23 was this highest one here. Slide it over. So we've got 3 different pieces to our range. 3 different pieces. We're going to have to name those individual pieces for our range. All 3 of them. We'll have to make 3 different inequalities. So the first inequality, let's talk about this one right here. Our highest value here would be at -5. Everything else is less than that. How would I show that? Y is less than -5. It's not equal to because it's an open circle. Y is less than -5. We have a point here at 2. It's just at 2, nothing else. So we would say that y equals 2. Y equals 2. And the third piece is going to be between what 2 numbers? What is our range between? 5 and 23. So we have to have a compound inequality here. Between 5 and 23. So I'll say that 5 is less than or equal to y is less than or equal to 23. That goes back to our inequalities that we solved. Cassandra?
Can you put 1 be an open circle? For the 2 spot?
Good question. It was an open circle, the endpoint, but these others are all closed circles on this point, on this line, so it's going to close in that open circle. Alright, again, remember your graphs have to pass the vertical line test. Does our graph pass the vertical line test? I know we have a lot going on. But yes, it should pass that vertical line test because I can draw a vertical line anywhere and it's only touching my graph in one place. Now, something to be careful of is when you've got, for example, if I take my graph and I move it right here, my vertical line, I move my vertical line right here. I'm looking at this open circle and closed circle. Is that okay to have an open and closed circle above each other? Yes, because one's a solution and one is not. What about right here? Looking right here, I've got an open and closed circle. Is that okay? Yes, but what if we had 2 closed circles? Then would it be okay? No, you would have done something wrong in your graph. It should always be a function. It's an easy way to make sure that you've graphed it correctly. Okay, tonight I'm going to ask you to do 2 problems. That's it, 2. I want you to get started right now in class. Your problems are going to be out of your book. You're graphing and you're identifying the domain and range. You take one and pass it back, please. On page 104, numbers 1 and 2. If you would like to do your graphs all in pencil if you would. But if you want to do your domains and ranges in a different color, I think it helps to see your domain and range a little bit easier if you've got a different color. You're welcome to do that.